Welcome to Chapter 6. This chapter we're going to do nothing but understanding division and the languages that go along with it and strategies that we can use to solve division problems. Our Common Core is operation and algebraic thinking. And if we look at our chapter vocabulary, we're going to start out with some new words and some that you've probably heard before. The word divide means to separate into equal groups. So if you think of the word divide, if you wanted to divide some cookies, you're going to separate them into groups. Your next word is dividend, and that is the number that is to be divided in a division problem. Divisor is the number that divides the dividend. So these two, you're just going to kind of have to memorize what they mean because they're so similar, and those words sometimes get flipped back and forth in our minds. So we're going to go ahead and pay special attention to those, and maybe it'd be a good idea to write these two in your math journal. Inverse operations is opposite operations. So inverse means opposite, or operations that undo one another, such as addition and subtraction. Okay, those are opposites. And the opposite of multiplication that we did last chapter is division. So inverse operations, opposite operations that you do. A quotient is the number, not including the remainder, that results from division. So results from divisions, it means the answer. Related facts is a set of related multiplication and division facts. We used to call these fact families. So if you do 3 times 4 equals 12, you have 4 times 3 equals 12. Those are related facts. And then you can go further with 12 divided by 4 equals 3, and 12 divided by 3 equals 4. So just like we did in our our addition and subtraction fact families, we have related facts of multiplication and division also because they are inverse operations. We're going to go ahead and start in your book today and looking at page 207. Showing what you know, check your understanding of important skills. So it's going to give us a couple of different ways to solve some, it looks like, subtraction and multiplication problems because those are inverse to our addition and our division problems. So it wants us to count back to subtract, even though we probably already know 8 minus 5. We're going to go ahead and use their number line, and we are going to count back 8 minus 5. 1, 2, 3, 4, 5, and that gives us 3. Go ahead and do number 2, please. Count equal groups to complete for number 3 and 4. So we're looking at how many groups do we have here? 1, 2, 3 groups. And how many are in each group? 1, 2. You have 2 in each group. And that's really all they want to know. Although you already know from the last chapter that would really be asking you 3 times 2 equals, and then counting 2, 4, and 6. 3 times 2 equals 6. Go ahead and complete number 4, please, the same way, counting the groups, and then counting how many ladybugs are in each group. And if you want to go ahead and write that multiplication problem there, that would be great. There's actually an inverse problem that we will learn to go with these using those 3 numbers. I bet you can kind of think of what that already is going to be, what your inverse or your related fact problems would be. 5, 6, and 7 are multiplication facts through 9. You can either work these through your memories using strategies of counting by 5. You can use your strategies of the distributive property. You can use the strategy of the commutative property if you know those. Go ahead and complete 5, 6, and 7. That page just helped us get our brains warmed up a little bit. And now we are on page 208, looking at our vocabulary builder. It says complete the bubble match by using the words with a check mark. So we're only going to use the words that have these check marks with them. And again, yours isn't going to be as hard to read as mine is because I had to blow mine up to get it on the smartboard. Looking at what it is like and what are some examples. This is a great bubble map because You have to be able to explain it in words and then do the examples, and that's what we've been working really hard on. Your first one, multiplication, talks about equal groups. Okay, and that's this first one with a check mark on it, equal groups. Okay, there's something else. If we look at our review words here, it talks about an array. Remember, the array are things that you can do, such as these, to help you solve a math problem. Equal groups is what we just talked about with the multiplication, making them into two groups of 2 gives you a multiplication sentence. Equation, we talked about last time. Equation is any problem with an equal sign. Okay, there's our equal sign, so this is therefore an equation. And we talked about how you can even have another symbol there to represent the missing number. So there's your equation. A factor is one with our check mark by it. And remember, a factor is part of a multiplication problem. So if I, again, have 3 times 2 equals 6, the 2 and the 3 are both factors in that problem. Identity property of multiplication, we have talked about for the last 3 chapters. Identity property of multiplication, remember, is any number times 1 equals that number. So you can kind of think of the 1, if you write identity, these two look similar in handwriting. So you can, anytime you see identity property of multiplication, you know that any number times 1 is that number. A product. The product is the answer to a multiplication problem. So again, I'm using 3 times 2 again. Remember, these two factors. This one is your product. Your answer is your product. Okay? Kind of think about if you're making something, then your end result is a product when you're making something. Your end result in a multiplication problem is also a product. Okay? You come up with something. Repeated addition, that is something new. Just the term, but if I do 2 plus 2 plus 2 plus 2, I'm repeating this addition, and it is the same as 2 times 4. And that's actually going to be our next one here with the multiplication. It's repeated addition. And again, yours will look much nicer in your book than mine does because of my big marker. Okay. So using what we just talked about on this other side with all of the explanation review of our vocabulary words, multiplication also is 4 groups with 3 in each group. Okay, that's a way of writing it out in examples. Another one here is a factor one that we just talked about. 6 times 3 equals 18. 6 times 4, it wants to know what this 4 is. And we just talked about this 4 being a factor. And 6 times 4 equals 24. It wants to know what the 24 is, and that's the answer, which we talked about being a product. Go ahead and fill those in. Remember, if I'm writing too fast or going too fast, you can always push the pause button. Understanding vocabulary on the bottom, draw a line to match each word or term with its definition. Now we might have some new ones that we have here. We have divide. We know that divide is breaking them into groups. We just talked about a dividend, and a dividend being the number that is divided in a division problem. A divisor is the number that divided the dividend. So these two are connected. Those are those two we thought we might need to write in our math journal. Inverse operation, again, those opposites. A quotient being the number in a division problem, so the answer, not including a remainder, which we'll get into later. And related facts that we just talked about also was kind of like your fact family that we learned before. So if we look at dividend, our first one, you're going to draw a line down to the bottom one because a dividend is the number that is to be divided in a division problem. Okay? So kind of think about how you can remember those. Dividend divided. Okay. A related fact is a set of multiplication and division equations. Notice they use the word equation here because each one of them is going to have an equal sign in them. So your next one, your divisor, is the number that divides the dividend. Go ahead and write those three, maybe at least these two, dividend and divisor, into your math journal before the end of today so that you can remember what those ones are. In your math journal for today, I want you to go ahead and set it up like a regular math journal entry. So here's your page. You're going to write chapter 6 on the top, and this was just the intro, so chapter 6 intro, okay, and then the date today. Okay, then on your first line, I want you to write problem of the day, and you can copy that right off of there, problem of the day. Okay, and it's a test prep question, which is good because we're getting ready for some tests. And Ashley made a picture graph to show how many books she read over the summer. She used this key. Each book equals 10 books. How many books does 2.5 books show? Remember to write your equation, and don't forget to label it. And then just go ahead and draw a line across the bottom, because we'll use the bottom of it next time. Adding to our math journals. Okay, we're going to go ahead and jump right in to 6.1. So you are going to turn to page 209 in your math book. And we're looking at problem solving today in a model of division. Our essential question you're going to write about at the end of this lesson, and you're going to write about how can you use the strategy acted out to solve problems with equal groups. So we're going to get up and moving a little bit today, and again a reference to our Common Core standard. Go ahead and get your name on the top of page 209. We're going to start by unlocking the problem like we do every lesson. Stacy has 16 flowers. She puts an equal number of flowers in each of 4 vases. How many flowers does Stacy put in each vase? Use the graphic organizer below to solve the problem. They're calling this entire thing down here their graphic organizer. So we're going to use this entire thing to fill it out. We're going to do it just a little bit different than they do. But first we're going to read the problem. What do I need to find? So let's go back into our problem and look at how many flowers does Stacy put in each vase. And remember, when you're solving story problems or word problems, you want to make sure that you underline those essential things that you want to be able to do so that you remember those as you're going through the problem, especially when you have such a big graphic organizer to fill out. And you should be thinking about using these, creating your own on scratch paper whenever you have word problems to help you solve those. So what do I need to find? I need to find the number of flowers Stacy puts in each vase. Okay. What information do I need to use? I need to go back into my problem and read it again. Just like reading, we reread, reread, reread. Okay? I know that Stacy has 16 flowers. She wants an equal number, and she has 4 vases. So an equal number, meaning each vase is going to get the same amount of flowers. She has 4 vases, and she has 16 flowers in all. So going back to our problem, Stacy has 16 flowers. Again, she's putting an equal number of flowers. And how many vases did she have before? Going back up into the problem, she has 4 vases. How will I use this information? It wants us to work on, I will act out the problem. Okay? Acting out doesn't necessarily mean you're going to go get 16 flowers and 4 vases, but you are going to make a visual for yourself to be able to do those. And what they want you to do is to use counters today. So by your computer, you will see a baggie of counters, and you are welcome to use those as you solve these. And we are going to make equal groups with those counters. So go ahead, if you're going to use the counters, count out 16 counters in all. So we're up here, first count out 16 counters. If you're going to use the counters, go ahead and pause right here as you get those 16 out. I am going to just draw mine because when I go to the computer lab or on some of our other programs or during testing, I probably am not going to have those counters to use. But I will always have scratch paper or a whiteboard that I can use. So I'm going to just draw mine, okay? Now we need 4 groups because she has 4 vases. So to start with, I would draw my 4 vases, okay? Place 1 counter at a time into each group until all 16 counters are used, okay? So if you're going to actually use the counters, you're going to make 4 separate groups on your workspace, okay? You might have to use the floor by your computer, or you can draw them out like I am, okay? So I have my 4 vases, my 4 groups. Next, I'm going to count out my 16. So 1, 2, 3, 4, keep going, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It wanted me to use equal groups. Each one of my vases or my groups all have the same number. So those are equal groups. And counting back, 1, 2, 3, 4, Stacy puts 4 flowers in each vase. That leads me to believe that 16 divided by 4 equals 4. If you are solid on those facts from the last 2 chapters, you know that 4 times 4 equals 16. There's your related facts, and that is a great check for you to be able to do when you're doing multiplication and division, because you can check those real fast with the same related fact families. Okay. If you are going to continue to use counters for this lesson, go ahead and leave them out, remembering that you have 16. And we are going to turn to page 210. Wants us to try another problem. It gives us a similar graphic organizer to use. Hayden is planning a party today. He bakes 21 cookies. That sounds like important information. I'm going to underline that. If he plans on giving each person 3 cookies, how many people will be at his party? Okay, so here's my question word. How many people will be at his party? What do I need to find? I need to find how many people will be at his party. And again, yours should be much nicer than mine is. What information do I need to use? Since I underlined when I was reading it the important information, I already have that done. So I know that he bakes 21 cookies. And I know that he wants to give each person 3 cookies. Okay, so I have 2 things of important information. It just happens to be the 2 things that I underlined when I was reading my problem. How are you going to use the information? Remember at the beginning of the lesson they wanted us to use counters, so we're going to make equal groups with counters. And they are calling that actually acting out, which is what they want you to do. So describe how to act out the problem to solve. So again, here's our big word, describe how to act out the problem to solve. If you're going to use the counters, you're going to count out 21 counters. Okay, then you're going to divide them into groups of, look back in your problem, 3. Okay, so again, I'm using the 2 numbers that I circled or underlined here because I knew they would be important as I was working them. Next, you can divide those with your actual physical counters. However, I am going to make groups of 3 until I get to 21. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so I made groups of 3, just like you will if you used the counters. I made equal groups of 3 for each one of these. Now I have to count to see how many actual groups that I made. So here's 1 group, 2, 3, 4, 5, 6, 7. So I have 7 people coming to the party. And my check is 3 times 7 equals 21. Okay? You could skip count by 3. You could also do 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3, which equals 21, which is the same as 3 times 7 equaling 21. Okay? So you could solve that problem by acting it out 2 different ways. By actually using physical counters, which is a great strategy until you get the hang of it. You could also draw it out, like I did here, groups of 3, until I get to that top number of 21, so that you know that those are going to be the correct answer. This that we just wrote down here is the same as explain or describe, because you are telling me how you got to that solution. Oh, that page looks messy now. We're going to go on to our next page, page 211, show and share. Okay, it gives us a couple of graphic organizers, and it gives us the fabulous show your work white space that you know I love to see filled up. Okay, unlocking the problem. If you look up in this top box, you're going to circle the question. We've done that before. You're going to underline the important facts, which is what I told you to do before. And then you're going to act out the problem with counters. Okay? So let's start by reading our problem. Sue is having a party. She has 16 cups. She puts them in 2 equal stacks. How many cups are in each stack? So here's our question. How many cups are in each stack? First, decide how to act out the problem. You can use counters to represent what we're counting. So we're counting out 16 cups. So our counters would represent our cups. Then you're just going to draw something to represent the stacks. So it looks like they have us circles here. So you're just going to draw circles to represent the stacks. Then draw to find the number of cups in each stack. Okay, so here's our 2 equal stacks. 1 stack, 2 stacks. Now we're going to count out our total number. So if we look back in the problem, she has 16 cups. She's going to put them in 2 equal stacks. Again, here's our 2 equal stacks, so we need to count out the 16. 1, 2, 3, 4. Don't forget to bundle those 5s so that when we go back to count, it will be easier. So I'm at 16. I counted out into the circles. There are blank groups. It already told us it wants 2 equal stacks, so there are 2 groups. Now it wants to know there are how many counters in each group. Since I bundled into 5, I can quickly count this as 5, 6, 7, 8 counters in each group. So there are 8 cups in each stack. This right here is showing your work, and it is describing. It's describing those words. It's describing and explaining how you got those answers, which is exactly what we want you to do every single time, which is why I drew 3 separate colored arrows to it. The only thing you're going to have to remember after doing that is to label, 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 label. Okay? Moving on to number 2. What if Sue has 24 cups and puts 4 cups in each stack? If she already made 4 stacks, how many more stacks does she need with the remaining cups? Okay, so she already made 4 stacks. And she's counting to 24. So she made 4 stacks, and she's put 4 cups in each stack. So in each one of these 4, I need to count out 4. Okay, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. I have 4 stacks of 4, which is 16. Now I have to figure out the difference between 16 and 24. So I can just keep adding stacks of 4. 17, 18, 19, 20, 21, 22, 23, 24. How many more stacks does she need? She needs 2 more stacks. And since I did this in my beautiful white space, there's my work that if I need to go back, it'll be super easy. Number 3, at Luke's school party, the children get into teams to play a game. If there are 35 children and they make teams of 5, how many teams will there be? So, get into teams. There are 35 kiddos, and they need teams of 5, so groups of 5. How many teams are there? So we're going to write groups of 5 until we get to 35. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So I'm at my 35, and I have groups of 5. So now all I have to do is count my groups. 1, 2, 3, 4, 5, 6, 7 groups. Again, getting into the habit of correcting and checking and redoing your work to make sure that you have it right. So I'm saying that 5 times the 7 groups equals 35. Is that a true statement? If it is a true statement, then I know that this is going to be right. And I know that counting by 5 times gives me a 35, so my answer is right. If I use the new strategy, 35 divided by 5 equals 7, those are related facts. They're using the same numbers, so it's a quick, easy check. Number 4, Annie puts 20 cupcakes on 4 plates. If she puts the same number of cupcakes on each plate, how many cupcakes did she put on each plate? Okay, so she has 20 cupcakes, and she has 4 plates. So I need 4 groups here. You can draw lines or circles, and then begin counting out the 20. Write your answer, and don't forget to label. Go ahead and do that one on your own. I think you can handle that one. Your next page is on your own. Okay, you're going to start out by using the table, so make sure you really use your strategies that we already know. Start with the title, figure out what each column is telling you and what they're each worth. Choose a strategy. You can act it out, draw a diagram, find a pattern, or make a table. Those are all things that we've already used. Okay, you're going to use the table for number 5 and 6. Okay, and then 7, 8, 9 are all strategies that we have learned in this lesson, and you have this beautiful white space over here to draw it out or to show how you did your counters. When you're done with that, you're going on to the essential question I want you to answer. We talked about at the beginning of the lesson. It says, how can you use the strategy acted out to solve a problem with equal groups? This is going into your math journal. Find a new page, This is lesson 6.1. Copy this onto here. Okay, keep copying it. And then in complete sentences, say, I can use the strategy acted out to solve a problem with equal groups, and tell me how. On that same page, here's your journal entry for today, your math journal. Write a word problem about equal groups and act it out to solve. So you have your essential question on the top that you just did up here. You're going to copy this down here, write a word problem. That just helps me know what your prompt was when I go back and read them. Okay? And then you're going to make a math problem. So go back on page 211 or 210 or 212. Look at those problems. Create your own problem. Okay, giving me a question with some numbers in it. And then show me how to solve it using counters or drawing it out, the acting out that they want. Okay? We will check these together when you are done and move on to your homework.